Luai, how are you?
Good, good. How's it going?
Good. Nice to meet you finally.
Yeah, nice to meet you. By the way, where are you staying at the moment?
I'm currently in New Jersey. It's
Oh, okay.
you're familiar with it?
Yeah, I'm familiar.
Cool. So you're in Dubai right now?
Yeah, I'm in Dubai at the moment.
Cool. So I guess to start us off, why don't
Yeah.
you give me a little backstory about yourself?
Okay, sure. I can do that. So actually, I'm an architect. So I graduated with a degree of science in architecture. It was a 5-year degree, bachelor's degree. Um, After that, to be honest, I'm always kind of not into the typical way of architecture, or to be honest, in anything. Like I'm more into technology and all of the new things that could help push whatever we're doing in the world forward. So immediately after I finished my bachelor's degree, I did work for 1 year. But then after I did a master's degree in advanced design and digital architecture, where I really got more into focus with digital fabrication techniques. And one of them was 3D printing and robotics. And quickly I started to shift more towards that direction. So I did have a chance to. I always had a passion also to work with parametric design tools. My main go to software was Rhino and Grasshopper. Um, I just love that flexibility. I don't know if you're familiar with Grasshopper, but
Yeah,
Grasshopper
sure.
is a parametric design software. It gives you almost ultimate freedom in design, geometrical shapes, flexibility, and it also saves you a lot of time into making iterations of multiple types of designs, or what you're aiming to do. So to couple that with digital fabrication and robotics, it kind of came to a perfect fit, right? Because you have digital fabrication tools on one side, and you have parametric design on the other, and the marriage of those both it just works perfectly because uh, in digital fabrication you do not want to generate your code every single time, and having parametric design be available for you to assist on that aspect. It just enables you to have ultimate freedom and flexibility and speed. Because today, actually, when I go into designing an object, a sculpture, furniture, architectural element, whatever it is, I can quickly come back to create a second version, a third version, and a fourth version, depending on feedback from various consultants or the client. And immediately the fabrication code is also there available for me without any delay. And then we can directly step into fabrication without having any delay and deliver the project within a few days. So that's what I'm doing here in Dubai. I did before I did digital fabrication, and in this case, focus on 3D concrete printing. I did do work in a typical architectural firm environment. I worked on one of the biggest Middle East infrastructure project with a Dutch company called Arcadis. I'm not sure if you're familiar with Arcadis. It's a Dutch design consultancy. And I was working in Doha, Qatar, for a year and a half on the Doha metro, which was basically in preparation for the upcoming World Cup. So we had designed a full metro system. So I worked on two lines, a red line and the gold line. They're color specific, and that specific project we delivered one of the most outstanding BIM architectural and engineering deliveries to the project. And still today, my previous company, which is Arcadis, They work on different projects today, but we always go back, the colleagues, we always go back to that specific project just to contemplate and think like how BIM managed to do miracles in that project in terms of coordination, solving clashes and problems with different engineering disciplines. So that also, prepped me for 3D concrete printing, because now we're one of the applications is obviously housing, and having all of that BIM knowledge also really helps with this kind of new technology, because you also want to make sure that you are using the tools that enable you to deliver a successful project, and having BIM and Revit as a kind of the way to implement the project helps making the delivery of the project successful. So yes, today I'm with this 3D concrete printing in Dubai.
Cool. So it's what I've heard about parametric design from other people that are doing 3D printed concrete is it's like a symbiotic relationship, so that the design software has been around for years and it's been pretty capable, but people come up with creative designs that are almost impossible to build by hand because there's so many curvatures and details that it would require such like a fine level of accuracy that it would just be time consuming for a person to do. But with giant 3D printers for construction, you can take these curvaceous 3D models that you can generate and make them at a more cost-effective basis than you would be able to otherwise. Is that correct?
Yeah, that's definitely correct. You could always, like parametric design tools, they have many different advantages and tools that you can utilize. One of them is optimization tools. And in the way of optimization tools, you can adapt 3D concrete printing as an application to finally optimize your structure and building to reach your goals, whatever your goals are in optimization. So it definitely helps a lot with the 3D concrete printing today.
So it sounds like the software is kind of taking a portion of the structural engineering workload and running calculations.
So the software has capacity to run structural calculations, of course, but in the project that we've worked on, we did not utilize that potential yet. We do the structural calculations with more traditional softwares. One of them is I'm not expert on them because I'm not really a structural engineer. But one of the projects, one of the softwares, was Diana, I think, and ETABS. That's what I hear from my colleagues. So we still, send the model back and forth between architectural, for example, Revit and Rhino, and the traditional structural engineering programs to kind of fix and adapt and optimize.
So to my understanding, when you're in school to be an architect, a huge portion of your course load is learning about traditional design styles and all the different ways throughout history that people have been building. And really, almost all architecture fits into some of those categories of like the traditional models, right? Yes. Was that your experience in university, or did you have like a more open-minded experience?
Well, that's what I was being taught in university. But of course, I'm always open-minded, and I always didn't want any kind of prehistoric methods or architectural ways to kind of dictate what I will be doing or how I should be designing as an architect. And actually, that's a really good point and a good question that you're asking, because many times I'm looking at architecture today, and some of the designs that we are doing for 3D concrete printing are kind of tied to the traditional mindset that we have. And it brings a huge question, which is, do we really adapt 3D concrete printing technologies to the traditional methods, or is there another way to go to better utilize 3D concrete printing? Because I personally think to match 3D concrete printing with traditional structural and architectural sides, it's not matching. We've been working with it for the past months and years, it just doesn't click. It doesn't match. There must be newly thought of and like innovative ways to bring 3D concrete printing using different structural and architectural techniques. So definitely it's an eye opener when you're working with new technology.
So when you were in university, were they exposing you to like cutting edge technologies and stuff like that, or
No.
was it really your own initiative?
No, they weren't really pushing me to new technologies, and part of that because the new technologies are really recent. I graduated from university. Oh my God, when did I graduate? I don't know, 10 years ago, something like that. 3D printing was not a thing back then. Like your normal desktop printer was not that famous as it is today. Other building techniques were not really popular. So no, what I was taught was a more traditional approach, and to be honest, I never really was into it because it just for me it was as if these techniques are there since years, hundreds of years. Why should I go explore more into it? It's been saturated and explored for quite a time. Let's look into something new.
Yeah, I totally get that. I agree 100%. And I think that most people in this space agree with you and are looking for like kind of the future. That's why people get interested in automated construction, automated anything, I guess.
Yeah.
It's interesting. I guess there's a lot of younger people in this space. It's not a lot of like gray-haired construction CEOs that have been doing work for like hundreds of years as GCs or whatever. It's mostly people who are kind of like learning as they go. And like you're working at a bigger company though, Besix supports Besix 3D, right?
Yes, that's true.
So how does that like organizational structure work? How independent from Besix is Besix 3D?
So we're not. So just to give you a little bit of background on how Besix 3D came about. So Besix itself, we have a kind of innovation program. It's called Unleash, where it asks young engineers, professional engineers, to come up with new ideas, innovative ideas, on how we can push construction into innovation. And Besix 3D concrete printing was one of those ideas that was chosen, and was chosen to be actually implemented in real life. And that was around 4 years ago when the idea was initially proposed. Over that period, a lot of research has been done, and Besix 3D, the actual 3D printing studio, was opened in December 2018 here in Dubai. And then when that's the time when we actually started hands-on experimenting, working, developing the material, developing the structures, all of those things. So today, Besix 3D, we're very dependent, of course, on our engineering department, for example, because we need structural feedback, we need support, even from our different departments. For example, our lifting department, our methods department. The thing is, we are working with a robotic arm, so we produce in a similar way to a prefab factory. So we 3D print a large structure, could be 1.5 tons of concrete in our studio, and then comes the question: how do we transport it? Well, what are we going to do with this? So we heavily depend on expertise from our other engineering departments, how to lift it, how to prop it, how to stack. If in case that we are building a multi-layer wall, for example, of 3 or 4 wall segments, 3D printed wall segments, we need to understand how do we connect them together, what type of layer we are going to use to bond them. How to lift one on top of the other, because many times in the early stages we were reverting to lifting these heavy structures from the bottom, because that kind of keeps the whole structure in compression, and you wouldn't be having to worry about failure in the structure. But then when we went one step ahead, where we are building a wall with 3 or 4 layers, then if we lift it from the bottom, for example, and place it on the first layer of walls, how do you get rid of that lifting growth, for example? So then we had to shift in the way that we think, and we need to think, okay, for example, we need to find a way to lift it from the top, so that when we place it on the first layer, it's clear and there's no left material, for example. So there's always some challenges that we're facing, and we're heavily dependent on our different departments in the company, and that's what's great about our department, Besix 3D. We've managed to actually advance a lot because we have all of that support. If we were just an independent department by ourselves, there's a lot of questions that we cannot answer by ourselves, you know.
Yeah, definitely. I'm sure that it's very useful to have a more experienced company kind of backing you and supporting the work that you guys are doing. You have printed a lot of projects, and I was scrolling through your the Besix 3D LinkedIn post. You guys have printed all kinds of like chairs, benches. The newest building, you built the facade. That's in addition to your office building?
Yes, so in Dubai, we've built in addition to the head office, the existing head office which was there for 50 years in Dubai, we've built 2 additional buildings. And there we saw a chance to implement one of the applications of this 3D concrete printing technologies. Is like, why don't we go ahead and 3D print the whole facade?
Yeah, I mean, that seems really meaningful to me, because for a company with a lot of construction experience, not just with 3D printed construction, when they're building their own building, you have to imagine they're putting a lot of consideration into like picking the best materials and making something that's going to last a long time. And as a construction company, you imagine that they'd put maybe even more effort into their own building than some project that they're doing, because they're going to be there for such a long time and they care about it. So it's meaningful that they would choose for a big portion of the addition of their building to be 3D printed. I'm wondering, if it's a facade, is it just the exterior that shows the layers, or can they be seen from the inside as well?
No, it's only the exterior. It's similar to your cladding, your stone cladding.
Yeah, sure.
For example, GRFC, marble cladding, any type of stone cladding. So it's basically attached only on the exterior. But you know, we have in this building, there's curtain walls running from the ground to the top. So when you're standing close to one of those curtain walls, you can easily look outside and you would see the whole panel in front of you. So it is visible from inside the building, but it is attached to the exterior.
Yeah, so it's not structural, just facade.
It is not structural. Yes, exactly. It's just cladding.
Cool. So being in Dubai, that's where they have the initiative where 30% of new buildings need to be 3D printed by 2030.
Yes, exactly.
So in your experience, I've heard people say, like, Dubai says that, but then they're not super helpful in pursuing permitting or financing and stuff like that. What has your experience been like there?
I mean, the thing is, Jared, it's a new field for everyone.
Yeah.
Here, even the municipalities and the clients and the construction companies. So what's been happening here is it's kind of like everyone is trying to understand this technology by themselves. You know, like, say for example, we as a construction company, we perfected the technology, we understood it inside and out, and we come and propose it to the municipality, for example. If they themselves, they don't understand it and they experience on a first degree level, they won't be able to communicate with us about what's happening, you know, about the technology. So I think what they are trying to do is also work on research projects by themselves, which they have. The Dubai municipality was able to print a 2-story building. Maybe you've seen it, which was also the largest 3D printed building in the world. So they have been working also in the background on trying to understand how this technology works and what is what does it mean in terms of permitting and etc. For us, definitely, because we work with new projects here, 3D printing projects, it's also a challenge. So whenever we have a project to permit, we go to the authorities, and we're faced with the fact that we're the first people applying for a similar kind of permit. So it takes time. It takes time, and it's still undergoing the process of getting those permits and getting the people who are responsible for issuing those permits to understand the technology. So we're trying our best to work together with them in collaborations and in close proximity to also teach them what we're doing and make them understand, so we can all benefit together, and we know how to move forward and how the permitting process should be taking place.
Sure, that's a good answer. So for all the fields in 3D printed construction, you have like the software, you have the hardware, you have the materials, and then you also have like general construction and just having a construction project that has like 3D printing with it, and also the material. So of all those things, what's the primary focus of Besix 3D? It seems to me like it's more about the software and the general construction process.
So, because we're coming from a general contractor mindset, so meaning that we finish a project from A to Z. We do the structure, we do the architectural, the finishes, everything. So Besix 3D, we're in the mindset we have a mindset that also applies the same concept. So we do not only focus on one aspect. Of course, we've tried to develop different areas in the technology, which is software, materials, structures, and etc. And we're trying to experiment with different applications, because we also think that focusing on only one aspect or one application for this technology doesn't really guarantee you that it's going to be the one leading in the construction sector. So we do develop different ones, and we see what's the market's response and the client's interest in that sense. But we do have a mindset that so actually today, just to give you an example, we have a project. It's a design and build project. It's from A to Z. We construct it fully and deliver it finished to the client. It's a 3D concrete printing project. It's still kind of a private project. We're not allowed to disclose the client or the project, but
Sure.
within the next 3 to 4 months, it's going to be finished, and it's going to be one of a kind project on a world large scale.
Very cool. The printer that you guys use, you use a robotic arm, a KUKA robotic arm, right?
Yes, that's true.
So is the printer head that you've developed a custom printer head, or did you outsource that from another company?
Yes, so we have partnerships with different companies. So we have a close relationship with the university in Eindhoven.
Okay.
You've seen some of their work. And we also have a good relationship with a Dutch design company called Vitrine and Bos. They're also working on a lot of 3D concrete projects in Netherlands and Europe. So that specific design for the nozzle, it was in collaboration with Vitrine and Bos. And we've stuck to that nozzle ever since we started the studio.
Cool. So I guess you guys are open to different printers, different hardwares if the technology develops.
Definitely. Yes, definitely. I mean, to be like today, what we're doing, as I said earlier, that we're doing kind of a prefabrication style factory. So we still manufacture smaller sized elements, and then we ship them onto site and assemble them together. Whatever the methodology was. but enable to move into a larger scale, into 2-story buildings, for example, hundreds of meter squares, you would need to probably use a larger scale printer, whether it be it on-site or off-site. That is also one of the factors that come into play when we kind of make a decision for that type of project.
Yeah. Okay. Can you talk a little bit more about the advantages of parametric design?
Yes, sure. So parametric design, I'm going to split it into two, right? I'm going to talk about parametric design by itself, and how parametric design, especially with digital fabrication tools, adds value. So parametric design by itself is basically getting rid of the traditional manual design, sketching, and modeling techniques, and more turning into more of a kind of a parameters-based design. So basically, it is a coding. So basically, Grasshopper is made in a programming language called Python, but it's instead of actual codes, you are dealing with nodes, like visual nodes, which represent those codes, right? So, for example, you would be creating mathematically, you're creating the curves and 3D geometries using that kind of programming language background. And instead of doing the sketching with your hand and entering the number and drawing whatever you need to draw and then extruding it and creating geometry out of it, you are designing a base code that has a lot of numbers, for example. Those numbers are called parameters, and these parameters enable, you can easily change those parameters in order to affect or change the end goal or the end geometry, which means if I make a circle and I have control over the radius of the circle, instead of drawing a circle that has 50 centimeter diameter, and then later on in a design stage I want it to be 60 or 70 centimeters in diameter, I would have it in a slider where I can just change that slider and it automatically changes those geometries. And that can be implemented on a more complicated and more advanced type of geometry that you're designing. So in that sense, it kind of cuts the necessity to regenerate and remodel and resketch every time you have a change in your design. And it also allows you a way to explore more possibilities, because you have some kind of generative design tools also that you can use, which basically you can program a code that basically you're telling it to find you certain geometries depending on criteria or end goal criteria that you want. So give me, for example, if you use environment, there's also, the thing is about Grasshopper, there's everything in it. Like everything that you can imagine, you can find in it. Physics engine, you have environmental analysis tools. So for example, you can design and one of the examples that I did actually for here in Dubai was a bus station stop, and I used a plugin for Grasshopper, which basically can calculate the amount of radiation that a certain surface or geometry is being how do you call it, exposed to. So
From
basically,
the sun.
Yeah, from the sun. So basically, you can tell this, you can write this algorithm and basically tell it, find me the most suitable geometry that can block the most amount of sun in this location. So it will give you different iterations of geometries, options, hundreds of options, and it would finally give you the most suitable shape that blocks the most amount of sun, for example. So that's the benefits of parametric design, that you are not restricted to your personal design preferences, because in a more typical architectural method, you envision a design, you come up with a concept, you draw it, you sketch it, and you try to implement it in a 3D manner or a 3D software. But with parametric design tools, you are not anymore the creator of the design from your mere imagination. You are creating a code to serve a certain purpose, and then the software would generate you those geometries. So you are still a designer, and sometimes when I talk about this type of methods, people are telling me, yeah, well, you're getting rid of the role of the architect. But it's not true. You are still dictating a lot of parameters and restrictions to the software, because the software can create you anything, right? It could create you a completely fuzzled geometry that is not usable. So your role as an architect in this situation is to define the limitations, define the goals, define what you're trying to reach, and get a really practical and accurate result at the end from this tool. That's the first aspect about parametric design. Maybe I've missed some things, because it's a really big topic.
Definitely.
The second aspect of it, if you connect it with digital fabrication tools, again, any changes to the geometry itself, because when we work with concrete, for example, there's the material itself gives you a lot of restrictions sometimes, like in terms of slopes, overhangs. Concrete is still concrete when you're printing with concrete, but how it is. It means you cannot print a surface like that, for example. You need to be restricted to certain angles, certain curvatures, certain geometries. So when you are experimenting with these new materials and 3D concrete printing technologies, parametric design is amazing. Why? Because any kind of changes you want to apply to the geometry to enhance it. For example, instead of having this slope, you want to enhance it a little bit, the curvatures, other restrictions, whether it's the hardware restrictions of the robot, the software restrictions, or the material restrictions. You can easily adopt it in parametric design, and immediately after 5-10 minutes, you're there to print the second version or the second iteration of your geometry. Mm-hmm. So it kind of speeds up the process of reaching to a really printable and practical design. So
that makes a lot of sense. That makes a lot of sense. It's almost like you can create a design you can draw the whole design, or you can draw a design that can redraw itself almost. And
exactly.
If you just change one parameter, like if you want to shift a wall a certain amount, maybe it'll know to shift the outlets and the light fixtures and the beams, if there's any beams or rebar that needs to be there. That sounds incredibly valuable, especially because there are always revisions to the drawings. Usually it's not like the first drawing is the one that gets built most of the time. So to be able to do that in one move of a slider, instead of clicking 100 lines, figuring out what to erase, what not to erase, and redoing it by hand, it just makes so much more sense, I guess. Yeah. I could imagine it would be frustrating for architects that learned a completely different style to have to kind of abandon what they're used to and learn a whole new way of designing with parameters instead of thinking of it as like set positions. But you're in a unique position. I guess you've been using this technology since the beginning of your career as an architect, right?
Yes, exactly. Actually, parametric design was something that I was always into on a personal interest level. So I started it while I was in university. Even in my third year of university, I started exploring it, working with it. Even Revit and BIM was always fascinating to me. How you can capture all of the information of the architectural project in a software. And I started working with it, and I never thought that at some point it would be so valuable as it is today. Because back then when I was using it, you know, like, and I went to specialize in it in my master's, still these technologies, these construction technologies were not available. They were not, they were, of course, they were available to a certain extent, but they were not that advanced that today we are like, as we're using them, as we are using them. So when I was doing my master's, for example, and doing all of this digital fabrication and parametric design and everything, many of my more traditional colleagues that would look at me and be like, dude, what are you doing? Like, look at 99% of the architectural studios. Like, nobody needs this stuff. Like, nobody wants it. Nobody uses it. Like, in Germany, for example, I've also lived 1 year in Germany where I did 6 months of learning in the university, and I had to do 6 months of internship during my bachelor's degree. I learned that a lot of German design companies, they tend to be really more traditional. They do not kind of go outside of the norms when it comes to an architectural project. It's just the way most of these companies are, and they are comfortable with. And a lot of clients are happy with that. Not a lot of clients are asking for crazy stuff. You know what I mean? So still, it was kind of challenging for me to convince people that what I'm studying or what I'm interested in could be valuable in one way or another.
Well, your timing was good because it's more valuable now than ever before.
Yeah, I'm so happy that's the case.
So the material that you guys use, you develop your own materials to print with?
So we are working with Sika. It's a huge concrete company. You're probably familiar with them. And they have a factory here in Dubai. So we work together hand in hand with them. We opened the 3D printing studio to develop the material. There was a base material that was developed by the team, by the Sika team. And of course, you never have a final result from the first kind of mix or design of material. So we worked over 6 months continuously, week in, week out, to develop this material together with them. We print in our 3D printing facility, and we invite them always, and we give them feedback on what's not working for us in terms of material properties. For example, that the material doesn't set as fast as it should. So when you are printing 3-4 layers, the lower layers are not set fast enough that the whole structure collapses, for example. On the other extreme, if the material sets too fast, which we had that in some of the material that we were testing with them, if the material sets too fast, then it ends up clogging your hose, which we use to deliver the concrete from the mixer.
Yeah.
So it plugs your hose. You don't have any way to pump that concrete anymore. So you need to find that fine balance between both extremes to have a material that could build up in a proper way, so you can build a 2-meter wall, for example. And that's just one of the aspects. For example, I'm just giving you an example.
I think I heard somewhere that Sika is experimenting with geopolymers.
I'm not really familiar. I haven't seen any work on that, but probably they could be.
Yeah, they're a big materials company. Maybe they are, I guess. So do you guys use rebar or other supports when you're printing the prefabricated objects?
So it depends. It depends on the type of geometry we're printing. If it's we've had some cases where we needed to use it, and we had some cases where we don't need to use it. But generally, we do not need to use it. Like
if you want to pick it up from the top part of it, you need rebar to.
So yeah, like today, for example, the way we're handling that is by introducing lifting hooks into the structure after printing. We can't do it while printing because the material is so sensitive and fresh. So we need to allow it to set properly. And then after that, sometimes we do additional casting afterwards with hooks. and then we lift it wherever we need, and then we can detach those hooks. So
Yeah.
the hook, the rebar is mainly used in ways that we need to lift the object or support it.
Do you experience, I guess since most of the objects you're printing are like kind of modular, so they're not like a single huge monolithic wall or anything, but do you encounter like cracks often?
So that was one of the topics that we had to address with Sika in terms of development of the material. Today, the material that we achieved is the final material that we've been using for over a year now. It does not crack. It does not shrink. It could withstand a lot of high temperature degrees, and it's just, maybe you've seen in the pictures, it has this white color that it's also really desirable for many of the clients, because when you're using concrete, typically you're talking about the dark grayish color that people are associating concrete with. But when you introduce it in a way that it has a kind of a new color, as simple as it is, people are looking at it in a different way. And it kind of differentiates 3D printing concrete for us from your typical concrete.
Yeah, that's a great point and a good strategy. The recent layers that you guys have been getting they seem incredibly uniform and smooth. And that's another, like, it looks discernibly different, especially when it has a different color from traditional concrete. And when the layers look so smooth and organized like that, it's almost like artisan.
Yeah.
A lot of companies, you can see the layers are kind of like wonky, not even, and it definitely takes away from the appeal of a 3D printed house. Like, yeah, it's still cool that it's automated, but it's not going to hit the like high market value that you have like in Dubai, where people expect a certain level of quality finish.
That's 100% true, and it's a comment that we've been receiving from a lot of our clients. Is like, of course, you have two kind of opinions on this topic. Many of our clients are really amazed and they are impressed with the quality of the finish, as you mentioned. Like, we've been able to achieve that nice smooth finish, not 100%, of course, but to a certain degree that it's more or less uniform. Some clients, on the other hand, we get questions that, so are you going to finish this product, or are you going to leave it as is? And depending, like, you can get a client that tells you, I want it to be finished and smooth, like a normal wall. You can get another client that says, no, I love it as it is. It's representing the technology, where it's coming from, leave it as it is, but like, as of today, I could say over 75% of the people that are our clients, or the people that we've worked with, they wanted to leave it as it is in the white color, with the layers showing, so it could represent where it's coming from. But it also has been a challenge, to reach that kind of smooth layer, consistent, and the texture and the quality looks nice. It hasn't been easy. We've done a lot of learning on how to achieve this. So there's a lot of things involved to achieving a nice finish. Like, a big percentage comes from the material, the mix itself, because you can get a chunky material. You can pump a chunky material that you will never receive a smooth, nice finish from it, right? Because it has bigger aggregates, and it will always have a sharp piece coming out, sticking out, so you will not have a nice, smooth finish. It could come from the mixer itself. That the mixer itself has its limitations also. And today, there isn't one specifically developed 3D concrete mixer. There are a few, but there are not a lot. We're still using typically the more traditional mixers that are not really designed to be used for 3D printing, but we're using them anyway because that's the only thing available in the market. We're hoping that actually the design for new 3D concrete printing mixers are being developed, because there's a lot of settings that you want to tweak and control while you're doing 3D concrete printing.
Yeah, I had a conversation with a couple other startups about this, and they had kind of tried to develop their own. One had tried to develop their own that had kind of sensors and
Mm-hmm.
could restrict the flow. Um, the other company was using a bigger company's pump, and they had similar complaints, like there's not enough control yet over the mixes. But that seems like a okay problem to have because it's achievable to fix it. We're at a place where the engineering capabilities of companies is like high enough that when they get that feedback, I think they'll be able to develop a pump that meets your specifications. And I think they have to think of it more as 3D printing and less of concrete, because you already have programs like I have a Prussia printer, which is just a desktop 3D printer that prints with plastic, and it has the Prussia slicer, and the slicer software has all these options for what material you're using, the size of the extruder, and all kinds of different options. So I guess as the industry advances as a whole, those developments will like become more readily available to you, and you'll have more tools in your repertoire. So
Hopefully.
have you ever read a book by any chance called The Fountainhead
No, I haven't.
by Ayn Rand? I think you'd like it. It's about an architect who goes to an architecture school, and
Okay.
he ends up hating it because they're only teaching him about the old styles and stuff. And he
Uh-huh.
does these designs that are kind of like not fitting into the old methods. Um,
Okay.
they end up like, I don't know. I don't want to tell you too much about the story, but it's a great book, The Fountainhead by
Okay,
Ayn
great.
Rand.
The
Uh,
Fountainhead.
the Fountainhead.
All right, that's I'll be definitely interested in reading that. It
Yeah,
looks
he
like
goes
some
into
of the
all kinds of
themes.
very unique architecture, and he tries to do like a project that's kind of like for low income, affordable housing stuff,
Mhm, mhm,
and
mhm,
it's just a huge, great story.
mhm,
Um,
mhm.
you reminded me of it a lot when you were just telling me about how
Yeah,
like
yeah, yeah,
being an architect, thinking outside the
yeah, yeah.
box.
Yeah, yeah. You actually reminded me of some situations now when you talk about that, of some of the discussions I've had with my professors. It's like sometimes like I was lucky that the professors are allowing me to pass the subject, just because we're on complete two ends of the spectrum. That we're not we're it's as if we're not talking the same language sometimes.
Yeah, definitely. And they maybe just didn't understand the technology, and it'll be interesting to see in the future. I'm sure some of them will see some of the work you're doing. Um,
Yeah,
maybe one day they'll write you.
I hope. I hope.
What are you guys
Definitely.
working on right now? Is like all the progress halted at the moment, or are you guys?
Not really. You know that's a really good point to raise, because it brings us to another discussion point, which is one of the advantages of this technology is you do not really need a big amount of labor work uh, to run this technology. Basically, in our day-to-day operation, I'm doing the parametric designs and the different designs of the geometries, and I'm generating the code for the robot to run the robot. But apart from that, I have two workers with me helping me in the operation. And because of that, it's kind of today in this special situation with the coronavirus, it's kind of a big advantage, because we don't need a lot of people. If we can maintain the distance between ourselves, we can still continue to run the operation, and that's what we're doing. Basically, we are. I was still in the studio today. We were printing yesterday. Um, we're still running because we don't have a big number of staff that forces us to shut down. So
Yeah,
that's one of
that's a
the
great
advantages.
point. I've worked on construction sites, and it's a lot of sometimes things are heavy. You need two people to carry them, or you're passing stuff back and forth.
Yep.
And sometimes you need to be in close proximity, and there's really no way to avoid it. But with this technology, it seems like you can have engineers working even in different parts of the world on a shared drive. And if they can upload the documents together, only one or two people actually needs to be with the printer. Everyone else could be anywhere with Wi-Fi.
Exactly, 100%.
So that's a really big advantage. But I guess the question is are we going to see that advantage come into play, or will it take longer for 3D printed construction to kind of like dominate the market? Will all this be in the past by then? Who knows?
Mm-hmm. Yeah, we'll have to see. I'm positive about that. I think people will understand more the benefits of this technology, specifically when we're talking about this point.
Mm-hmm.
Today, we only have one robot, but if you can imagine that we have clusters of this 3D printing studio that we have, if we have 3 or 4 of them, you can run them separately in a completely safe environment, and you can still completely run your operation without having to stop. So that I hope that's one of the things that would come as a benefit from the situation.
Do you think that 30% of all buildings 3D printed by 2030 in Dubai is a realistic goal?
I think, just to be more specific, I think it was 25%.
Okay, yeah.
In 2030.
Yeah.
So the way that Dubai is tackling this, we're also working with the Dubai Future Foundation, which is kind of overseeing this 3D printing technology and how it develops in Dubai. The way they're trying to achieve this is by reaching a certain percentage every year. So advancing slowly by bits by bits, slowly, and kind of compound what we learn and what we know that we can do as 3D printing in the buildings. 3D printing, 25% of the buildings 3D printed by 2030. I don't think it's a far-reached goal. Today we're already way more advanced than a couple of years ago in this technology, and we are in a step where we can kind of implement it on a larger scale. So I think what's going to happen now is there's going to be it's going to take some time, but we're going to start to shift from smaller scale 3D printing into larger scale 3D printing. We are already considered large 3D concrete printing scale compared to your plastic printing, but still there's an extra step to take it. Yeah. Because that big scale is by itself small scale to itself if you compare it with itself, but there's potential for it to expand into a larger.
Especially in Dubai, where they have the tallest building in the world.
Yeah, that's true. Exactly. If it's one place where it's gonna happen, I think it's gonna happen. It's gonna be in Dubai.
I think so too.
And I think 25% it's achievable. And when we talk about 25%, it's not necessarily concrete. Just for you to know, it could be any kind of other materials. It could be, for example, that accessories in the building, doorknobs, window frames, any kind of building component. It could be part of that 25%. Of course, concrete would occupy the largest because it's just the how do you call it? The amounts of concrete that you are using in a building are big, and it's
you could say maybe the most abundant.
Yeah, there you go. Exactly. It's the most abundant, and it's the one of the materials that you can achieve a big I don't want to say scale. I want to say volume. It's the material that you can achieve really high volumes in low amounts of time. Concrete.
Yeah. So would that measurement of 25% of the building be by volume or mass?
I think it's going to be. I really don't know. It could be either.
Or by cost.
I feel it's going to be by volume, because look, today you can print a 2 meter by 1 meter wall which is thickness of 15 centimeters in 3D, and that will occupy a certain space in your building. But it doesn't need to be 100% full inside. You can have it hollow, to 50% or 40% hollow, and you can still achieve that, occupy that volume, right? So what I feel it's more appropriate is to have it as a volume instead of mass, because then it will be occupying a certain space around you. But we will see how it's going to be calculated at the end.
So it gets very hot in Dubai, I understand. How do you deal with the insulation?
So, like today we're still using typical insulation methods with 3D concrete printing. One of the aspects that we are trying to really address is the thermal bridging between the different components, because we are printing, different like modules or different kind of segments, and we're assembling on site. So you have always there's a connection between the two pieces, whether it's vertical connection or horizontal connection. And one of the challenges was the thermal bridging, and how do we make sure to insulate properly the whole building, the envelope of the building. So there are different types of insulation materials also that could serve better for 3D concrete printing. We're looking at, for example, foam, expanded foam insulation, which kind of expands and fills up your cavities. And the reason why we're using it as one of the insulation materials is because we try to achieve those cavities to reduce the amount of infill, to have a lighter structure, and to only enable the structural to work within the capacity it was designed for. So many times we could end up with 50%, for example, hollow spaces inside. So we with expanded foam, you can easily occupy those areas. So that's one of the things we're looking at. But it is still a challenge.
Interesting. So have you experimented much with putting windows in or doors?
Yes. So for the project that we're working with, it's a small building, around 65 square meters, one-story building where we have a lot of doors and a lot of windows. So to be honest, because we are doing smaller modules and bringing them, stacking them together, at the end of the day, we will still have, as a traditional building would have, we would still have that opening where we would insert our window frame or a door frame. So it's not a challenge for us because we're not printing on site. But if you would be printing on site, for example, you would need to probably have support under your opening and then print on top of that, and then remove the support to be able to insert your window frame or door frame.
And so what do you generally use as a support?
We don't need support because, as I mentioned, we're doing like segments, prefabricated wall segments, and then stacking them together on site. So we find ways. Of course, many times we need to use scaffolding and propping systems to hold the lintels, for example. But then after we fix the lintels in place, you can remove your scaffolding and then you can put your window frame.
Okay. So here's a question I like to ask people that I do this video call with. Is there anything that you've printed that you keep in your house?
Yeah. You want to see it?
Yeah, sure.
It's a small funny thing. Of course, because concrete is heavy, so it's not easy just to get some of the pieces. But one of my favorite pieces is this one.
Cool.
So that's basically a drop of concrete coming from the nozzle. If you would have the nozzle like that, elevated from the print floor.
Oh, and you splat on the ground.
This is just one drop that dropped from the robot while he was moving, and when it dropped on the floor, it just still had that motion of the robot with it, because the robot was moving in this direction.
Yeah.
And then when it dropped, it just left that shape and dried out. So I keep this at home.
Yeah, it's like a paperweight or a sculpture, small sculpture.
Exactly. I just love it, and I just keep it here.
That's funny. Some people do, some people don't keep something with them. It's very clear that you have a passion for the work that you're doing.
Thanks for saying that. Appreciate it.
Is
I
there,
do. I
do you feel that really helps you with your work? Like, does the work feel like
Of
work?
course. Of course. That's because as you said, because it is a passion for me. It doesn't really feel like. Of course, it's work. You know, at the end of the day, we have projects that we need to deliver, and we have stressful moments and periods where I need to work extra hours to deliver certain deliverables. But still, on a day-to-day basis, because it's a passion, it makes it much easier for me to do, and I enjoy it, and I'm always excited to come up with new solutions, and I like it, and I like it because with a new technology that you are working with, you have a lot of problems to solve and a lot of questions that they don't have answers, or the answers do not exist. And because of that, I really enjoy it, because I'm always faced with the new challenges and new questions and problems, and we need to solve, and we look at some different solutions. What's the best way to tackle it and address it, and we come up with the solution. And when the solution works, I'm the happiest person alive.
Yeah, I'm sure it can be very struggling at times to get to that solution. Like with all engineering, there's always a lot of trial error. Um,
Yeah.
but with all the progress you guys are making, I'm sure there was a huge learning curve, and now you're almost at a point where you can. Sounds like you can make a pretty complicated design and have a good idea of whether or not it's going to print well. Um,
Yep.
so when you come up with a new design now, when I'm 3D printing stuff, even if I'm downloading models from the internet that I know worked for other people, the print doesn't always work for me. So I run into issues all the time. And with plastic, it's easy for me to just take the print off, throw the half plastic piece in the trash. But if you're printing something big with concrete and you run into some mistake, that's a 1,000-pound piece of material that you need to get rid of. So how do you guys deal with that? Have you just reached a point where there's not so many mistakes anymore, or are you crumbling a lot of old concrete?
Yeah, definitely. In the first months, in the first periods, we had to throw a lot of concrete, and mainly, it's either learning from the geometry that we were trying to build, or it came due to the material itself, because the material itself was still under development. But after that period of time, the 6 months that I talked about for developing the material, we were only more faced with the failure of the geometries. But slowly, with experience, day in and day out, we know now the limitations, and we don't run into a lot of failures in geometries. And if we do, we are trying to develop some sustainable solutions where we can recycle that concrete and reuse it. I don't know if you saw that picture on LinkedIn with the new, you did mention that you saw it with the new facade, the 3D printed facade. If you look in front of the facade on the ground, you actually see small chunks of concrete. If you open it in front of you, I can describe it to you. You see small chunks of concrete. Basically, that's recycled 3D concrete printing concrete.
Oh, like gravel.
Yes, gravel. So we managed to take some of the waste and run it into gravel to be able to utilize it instead of throwing it away.
Yeah, that's a good way to recycle it pretty quickly without having to process it more than just crumbling it. Yeah. How do you crumble it though? With a sledgehammer?
We have all sorts of equipment, like heavy duty equipment in our yard. So
it's mostly automated.
It's crushing it into smaller pebbles.
Yeah, in old American movies and cartoons, they always have jails where people are in a jail yard with a hammer, just crushing up big rocks or something for gravel. I don't know if they do that anymore, but I don't know why I thought of that. Anyway, so you're personally deeply invested in parametric design. Where do you see yourself kind of expanding in the future? Do you think you're going to continue to have expertise in parametric design, or will you kind of dedicate your experience to 3D concrete printing? Like, where do you see yourself going?
The thing is, like, I don't see them as two separate things. I think they're very well connected, and to be able to excel in one of the directions, you need to also excel in the other. So I see myself as more exploring more techniques and more ways to utilize these tools, because it's a vast ocean of tools that you can use, and of course maybe more focused into the architectural way of it. So how to bring the whole architectural concept together with these techniques. So I hope these new developments happen with 3D concrete printing. If it's going large scale, utilizing more tools, and so on. And I think with those also a kind of advancement, it pushes you also to go into certain directions. So we'll have to see how that turns out.
Do you think that most architects now are being exposed to parametric design in their education?
I can't really tell you like a definitive answer, because it depends really on which country, which education system and things like that. But I can definitely tell you that I'm meeting more people that are interested in parametric design, and they're more familiar with parametric design than I did before. So I think a lot of people are going more towards learning those techniques and those tools, and also into BIM, for example. BIM is being invested heavily in. People have really, like construction companies or engineering consultants, they've really saw the benefits of BIM. And I think a lot of people are getting into BIM, and that helps us also. Because if we need to go back and forth, we need to be able to to have both parties understand the same working methods.
Sure. So when you are utilizing parametric design to build a model, are there parameters that you can basically copy paste from old projects with new projects and then reform it? Like, I know you built the chair, and then you also built the like sun chair, which was like a longer chair. You're able to kind of make the process easier and recycle those?
Definitely. Yes, definitely. So in parametric design, it's sometimes you are trying to achieve the same thing again in a certain design, and with the experience, it comes to you to a point that where you can actually say, oh, I actually use this technique in this design. So instead of going and doing it all over again, you just copy that part of the code and you just paste it in your new code, and you just build on top of that. So definitely it's there are a lot of techniques and tricks that you learn with experience with working with parametric design, and if you have 20 codes saved on the side, for sure you can pull up parts of each some of those codes and use them in new codes that you're generating.
Will there be a software where you can kind of make like a free form design, maybe just like draw an outline, and then the parametric model can turn it into a printable wall with the interior structures? Or
Yep. That's actually some of the codes that that I'm working with now. And some of the codes that I've developed are basically a base curve. You just need to insert or draw a base curve. The code would take it, analyze it, see the limitations of that certain curve, for example. It could draw that curve into something that is actually printable or that is feasible for 3D printing, and then it would build from that regenerated curve a complete model ready for 3D printing.
Wow. So if it can generate a model that's a 3D model, and then you could import that into Revit, an interior designer or someone could easily make a realistic looking model of the design pretty quickly. So as far as
we're working with that. We've done that exactly like you described. We've done that. we export the model into Revit, and we work with it, even with different disciplines. So we work with MEP engineers, structural engineers, all those necessary for a project. We pull that model, the parametric model, and we work with it on Revit, and we have all of the experts put in their information and their
Yeah, when people think about the construction cost savings and time savings for 3D printed construction, I think mostly they're thinking about the savings of having a printer laying the cement versus having a person stack bricks or blocks, whatever it is. I think a lot of people glaze over these kind of more engineering concepts that involve the software and how much time savings it is for someone to be able to just download a 100% accurate 3D model versus having to take maybe a 2D floor plan or something like that and design the model from the ground up from Reddit.
Definitely.
If you were to give an estimate of the time savings just from like the before construction side, when you implement softwares like this, how much time is saved from the engineer's perspective?
It's large amount of time saved. Just the fact that you don't need to remodel a design from a simple comment from the client. Imagine the amount of time that you are saving there. If you can just enter a new number into a parameter and just have that fixed there, I would say at least you are saving 50% of the time, at least, from not having to regenerate the models, from the regeneration of the geometries, the techniques that we are using to generate print codes, and so on. To jump from design to production, it's insane. Like, you're saving a lot of time. We had a project where we had a client come in to talk together about a certain design of geometries, outdoor furniture and sculptures, and we were literally from that day, 2 weeks ahead, we were literally delivering the project.
Wow.
In 2 weeks time, and that's never heard of before. Having to sit down with a client, and in 2 weeks time you're actually delivering the project. So that's the benefit of these technologies. They push so fast the time between design and production.
Yeah, especially considering how young the industry is of parametric design and automated construction. It's incredible that those time benefits are already being realized when they're only going to increase in the future. Like, as fast as it is now, it's only going to get faster, of course. Nothing's going to slow it down.
That's true.
So it's going to be incredible to see the difference that it makes. I guess the goal that Dubai has becomes extremely realistic if there's a cost effectiveness behind the 3D printing as well. So the municipalities printed that building, the 2-floor building, and you guys did your building with the facade. Are other big organizations in Dubai trying to do 3D printed construction right now?
Yeah, I think it's a general theme in Dubai. Normally the governmental institutes are also trying to go in the same direction of the vision. So we get a lot of interest from, we have a lot of conversations and discussions with different ministries, trying to understand and trying to see where they can add a benefit to their projects utilizing these technologies. So I definitely think a lot of people are trying to invest in understanding and implementing part of their projects in this technology, and that's a really important step, by the way, because that step by itself, it's kind of like also involves an kind of awareness, spreading awareness to the clients and the designers, because we also faced a problem many times that we go into conversations with some clients and designers, and they just think that we can print anything. Like, literally print anything that we want. But again, we try to educate them and tell them, okay, this is our restrictions. We can't print everything. There are certain criteria for a design. We need to stick to this kind of parameters, this kind of restrictions, and so on. So it's also something that we invest a lot of energy and time in, is like trying to educate the market and trying to educate all of the other parties involved on what is actually 3D printing and what can we achieve with it. So that's the first phase that needs to be passed. And then after that phase, you can really have a conversation about something that is 3D printed.
Yeah, I was about to ask you a question along those lines. Like, how often do people contact you with unrealistic expectations?
The whole time, every time, almost every single time.
Yeah, because they just want something huge, or
yeah, but it's also because of a lot of claims from some of the companies, some of the startups and the 3D concrete printing companies. I've seen videos saying that you can print something in 48 hours, 24 hours, whatever, for $3,000 or something. Come on, let's be realistic. That's never gonna happen. That's never the case, and that's never gonna happen. These kind of information, it's what's spreading on social media, and that's what people say, and that's what people see. That's what people come to us and claim. They're like, what are you talking about? You need 2 months to print me a small building? I've seen a video that says in 48 hours they printed the whole thing.
And the problem is, those are the videos that get all the views.
Oh my God, yeah.
They get like millions of views when they make kind of like maybe unrealistic promises and inflating expectations.
Yeah.
I don't know. It's kind of good for the industry because it makes more people aware of it. I think like most people, that's the only exposure they get for it. Like spreading awareness is good, but at the same time, to set all those expectations at that level may be unrealistic. I mean, it's certainly unrealistic. If it was true, then you would see so many houses and whatever being 3D printed right now.
Yeah.
Whereas obviously millions of people saw that video saying you could like 3D print a house for $4,000 or whatever. And there's like less than maybe a dozen of them.
Yeah. Like the way that it affected us, it was it had a negative effect, those kind of claims, because what we're trying to do here is we're trying to do something realistic and do something honest and something that our clients can trust. But then when you have all of those claims floating around, it makes just our job a bit more difficult to try to convince people what the reality is.
Yeah, that's a big difference between a company that's kind of like more mature and has a lot of experience like Besix and like a startup that's just trying to generate hype for themselves. Besix doesn't need to do so much publicity because they already have tremendous network of clients, experience, and repertoire. I could definitely imagine it wasting a ton of time when people go to you and you go through all the details and contact, maybe have hour-long conversations, and then realize at the end of the day their expectations are just unrealistic and it's not going to come to fruition. I'm sure that's frustrating.
Yes.
But hopefully, I guess with time, the market will come to understand where the technology is, I guess. It's kind of a reason that I like to do these videos, is so that people can get like a deeper understanding from people like you who are like actually working with the technology hands-on. And ultimately, if they're interested in doing a project, be able to contact you with some like understanding of what's going on rather than just the 2-minute video clip that they saw on Facebook.
Exactly. Yeah.
I could totally see the frustration. I first discovered 3D printed construction from one of those videos. So I have to like appreciate it a little bit, just for like exposing me to it.
Okay.
But yeah, I mean, $4,000 for a house, definitely not a realistic claim.
No, you would definitely see all people already living in those houses. I would buy that house.
Yeah.
I don't want to pay rent, crazy amounts of rent if I can get a house for $4,000. So yeah.
So you live right in Dubai?
Yes, I live in Dubai Marina. If you want to see a view where I'm living from, it's like
Oh, wow,
this is
that's
the marina.
beautiful.
Yep. So this is the Dubai Marina. It's a really nice area. A lot of expats live here. Um, there's everything here, and it's just nice that here it's really kind of isolated from the main streets. So it's really quiet. You can walk downstairs. You have all of the facilities. You have anything that you want. Yeah, Dubai. I love Dubai. I love living in Dubai. I love the vision that the leaders of Dubai have, how to push the country forward, how to be the leaders in different technologies and different sectors in the world. It just makes you feel that you are part of that evolution, that part of that um, development that's been happening, and that's what I really like about living in Dubai.
Yeah, that's awesome. I'm definitely planning on trying to visit Dubai when I can. I don't know when that's going to be
Oh,
exactly because
yeah,
of the.
you should definitely let me know when you visit, and I can show you around our printing facility, even around Dubai.
Yeah, that would be awesome. Thank you.
Yeah, you're
So,
welcome.
where are you originally from?
I'm from Jordan.
Jordan.
Yes.
And English is not your first language then?
No, Arabic is my first language actually. But you know, we learn English in from kindergarten, from even as far as I remember, from kindergarten in Jordan. We learn it as a kind of second language or an additional language. Almost every Jordanian that I went to with in university speaks English, can communicate in English. Different levels, of course, but more or less can communicate in English. My studies that I did in universities, my bachelor degree in architecture, it was all in English.
So, growing up in Jordan, were you exposed to a lot of conflict there?
Not really. Jordan is one of the more calmer countries in the region. You never really hear a lot about Jordan in the news in terms of conflicts, and that's one of the things that we've been blessed with in comparison to some of our neighbors in
Yeah,
the
Jordan
region.
is right next to Israel, right?
Yes, it's just next to. So Palestine is on the west bank of the River Jordan, and then Jordan is on the east bank. So you have Jordan, Palestine, Syria on the north, Iraq on the east, and then Saudi Arabia from the south.
That's fascinating that Jordan manages to stay out of trouble with all those neighbors.
Oh
Uh,
yeah, oh yeah,
because there's so much conflict in that area, but you're right. Like you never really hear issues.
everywhere. On almost every single border except the Saudi border, there are conflicts. But Jordan has managed to do well.
So you left mostly just for university?
So I did. So I am also like part of my living lifestyle is exploring different countries and destinations. So
Cool.
during my bachelor's degree, I did spend 1 year in Germany. I did my master's degree in Barcelona, Spain. In those two different experiences, I got the chance to learn German from living in Germany, and I got a chance to learn Spanish from living in Barcelona.
Wow.
Yeah, and then I did work in Doha, Qatar, for that project, the Doha Metro project. And then I met my wife, who she's from Slovakia. So I had to move to Slovakia, where I lived together with her for around 1 year and a half. I did try to learn Slovak, but Slovak it was really difficult language for me, so I
Uh-huh.
didn't really do well as I did in Germany or Spain. And then eventually we ended up moving here to Dubai.
Wow, you're extremely well traveled. So you speak four languages.
Yes, yep. English, Arabic, German, and Spanish. Spanish not so fluent, but a good level, and very big, like extremely a beginner in Slovak language.
Is there a lot of like international conversation going on with B6 3D international clients that you have to utilize those languages with, or
Um, Not really, unfortunately not. It seems that English is the universal business language these days. So the majority of the people, because you in a certain team you would have different people from different countries, and the only language in common between different teams of different companies would be English. So we mainly use English.
So Dubai, not a lot of people are actually from Dubai originally. It's a lot of foreigners.
Yes, there's a big percentage of expats living here in Dubai. I'm not sure about the percentage, but could be 50% or above 50%.
And so you're saying among the expats, primarily English is spoken because that's like
Yeah,
common.
exactly. Because you have people from Eastern Asia, you have people from the Middle East, you have people from Europe, from Americas. So English at the end of the day, and Africa. I don't want to forget Africa. If there's any African countries watching, they're going to be mad. But like you have all those people from different countries and backgrounds. So English is the one language that unifies us.
Yeah, there's one company I know of that's doing 3D printed construction, an African company that I've
Okay.
seen so far.
Oh,
They,
okay. Do you know the name?
um, I do know the name. Let me pull it up.
Because I've seen your video with the companies around the world that are doing 3D concrete printing.
Yeah, it's called 3D Printcrete.
3D printing.
I had that one first video with 30 companies, and then I did a second video with 28
Uh-huh.
more.
Oh, okay, yeah, I remember.
3D Printcrete was in the second video.
Okay.
Yeah, they had a project. They just printed like basically a circle. It wasn't very
Uh-huh.
complicated, and you couldn't really see the printer either. I think it was
Okay.
probably a gantry style printer.
Mm-hmm.
Yeah, I would say B6 3D is quite a bit more advanced than the progress that they're making there. So I guess Dubai is really going to be the concentration for 3D printed construction in the next like 5 to 10 years, certainly. So yeah, I guess you picture yourself staying there for a while.
Yep. I would love
And
to see, this technology where it's going to head.
yeah, how long do you think before you move into a 3D printed house potentially?
Wow, that's a good question. um, 5 years, 5 to 7 years.
Yeah, that's a pretty realistic time frame, I think. Especially if you're willing to kind of be an early adopter.
Exactly. That's always there's a question if you're willing to be an early adopter now.
So
Hi.
you mentioned that the material that you use has a high heat potential or can withstand high temperatures.
Yep.
Can they withstand high enough temperatures to be used for like a fireplace?
Uh, I don't really know. Do you know the temperatures that the fireplace would typically reach?
To be safe, say maybe 700 Celsius.
700 Celsius. Oh, I don't. I'm not sure, to be honest. I don't know.
That's pretty high.
Maybe that's a bit high. I don't. The thing is about the 3D concrete is it's also very similar to the normal concrete in some ways. So whatever kind of applies to your normal concrete would generally also apply to 3D concrete. So,
Yeah, generally they would make a fireplace with brick instead
yeah,
of
exactly.
concrete.
Yeah.
But I guess you can't really print in a brick material.
Not really.
Interesting. Yeah, I
But
mean,
you could 3D print a fireplace and clad it with bricks just on a single layer, for example. There are ways to achieve something using like a hybrid technique sometimes. So that could be one of the ways to do it.
how challenging is it to print something that holds water?
It is quite challenging because the material that we are using is not that strong in tensile forces. So if you have a large volume of water, your
The
structure,
pressure outward is too much.
yeah, could easily crack. It also depends on the design, right? If you could manage to design something that has a really thick and sturdy perimeter, that could be something that would hold more amounts of. But if you're talking about a single layer structure, it wouldn't hold much.
So what kind of people do you think the 3D printed construction industry needs to advance right now? Like, do you need more engineers, more materials experts, more software experts? Which is like which space needs the most more people?
We need definitely a lot of movement to be happening in the equipment side of 3D printing, the mixing machines, the nozzles, the communication between the robot and the mixer, because sometimes you need to stop and start again. That is still not something that we have. And also, of course, you need the experts and the software. I would say the software are there. They are really sufficient to be used for 3D concrete printing. You would need a lot of the experts. Second thing I would say that the experts, you need the new engineers and designers and architects even, to understand the potential and the restrictions of this technology.
Sure. So at this point, you guys have done a ton of prints, and I guess developed almost like a catalog of what your printer's capable of. Are you selling those prints, or still just in like an experimentation phase?
No, definitely. We're in a phase where we are selling to clients some of the designs. I'm not sure if you saw one of the projects that we had. It was like a sculptural project.
Yeah.
Where we did a hybrid between plastic and 3D concrete printing, and we had it displayed here in one of the art events in Dubai, in a really central location. So we are producing final products to different kind of clients.
So do you picture Besix ever like releasing that catalog of printable projects or anything, either for profit?
Yeah, we are actually finalizing, if not we have finalized a website for Besix 3D, where we are publishing all of those projects and the catalog of products that we are able to print. So I mean, maybe 1 month time or 2 months time, we have it up and running.
Really cool. And will that include the STL files, or it'll just be like a little bio about each?
Oh, I don't think it will include the STL file. It will just include, the photos, the description of the project, the potential probably, where you can tweak things. But yeah, in a way to be able to showcase, what we can do and what we can print.
Yeah, I think that ultimately there'll be some company that has the business model of just like having the designs where people can like download them, buy the design, and just if they already have a printer, go ahead and print it. Obviously, yeah, there aren't really enough printers for that to be like a profitable business model yet.
Exactly. Yeah, but it is an interesting idea. Yeah.
Yeah, especially since it seems like a big part of like your expertise is in the software and the design part. It would be really interesting if because it has the parametric design, it has like the sliders, like you said, but yeah, you need to have a deep level of understanding to kind of get into the software and go into the nodes and know the correct sliders and parameters to change.
Yes.
I guess it'd be interesting if the software could somehow create a user interface that allows a less experienced person to look at a model, yeah, and be able to.
So I would. There are already existing softwares that you're describing, and we already actually experimented with them. And I can give you the name, and you can check it out. It's exactly like you're describing. It enables anyone just to play around with the sliders and what is it called? I think it's called Shape Diver. I will check for you. Shape Diver. Yes. So if you go to shapediver.com, it's a really interesting company. I think they have some of the. So yeah, you can go to the homepage and under the menu you can check the product and then 3D product configurators. So these are exactly that you are mentioning. You can, as a even as a beginner, you can just play around with the nodes and create your parametric models almost instantaneously.
Yeah, wow, that's really cool. And then it allows people to use kind of like virtual reality to see what it would look like.
Well, I think I'm not sure if it's part of this software, but I'm pretty sure there are other companies doing that.
Shapediver.com.
Yes, shipdiver.com.
Yeah, I'm on it right now. It says 3D visualization for product configurators. Okay, the configurator part.
On the left side, if you go on menu and then go to product, and under product you find the 3D product configurators.
Wow, so you guys are actively kind of using technology like this?
Yeah, we were in touch with Shapediver to see how we can also utilize some of those interfaces, because really it brings the connection between us, the designers, and the users, because it also gives them freedom to play around and produce some geometries.
It's like the old saying, if you give a man a fish, he'll have food for a day, but if you teach a man to fish, he'll have food for life.
Yeah.
So this software almost teaches people how to fish if they can adjust the sliders and make changes themselves. Like an architect or designer could come up with a model for a table or a desk, and then a person could download that model and then resize it so that it shares the like design style that the architect originally had in mind, but now fits the custom space that that a client had in mind. And so it's like they don't have to be the creative part, they don't have to be the creative influence in the design, but they do get all the benefits of the customization at zero time cost to the initial designer.
That's exactly true. Yeah.
I don't know if a lot of people understand that concept yet. I mean, I'm really only beginning to grasp the value of that after having conversations like this. But I really think that most people who are even looking into this space and considering it are overlooking that added advantage and like not really grasping what it means in reality. Like it's one thing to talk about a concept, a desk that you can download and custom print. That all sounds very futuristic and kind of imaginary, but like we're kind of already there right now.
Yeah, I agree with you. I think it's more about exposure and being able to deliver that message to a wider audience and spreading it out.
Yeah, that's kind of a tricky part when the audience wants like very specific things, like the $4,000 house. It's like, I guess it'll really take some serious education for the masses to understand the technology. Has Besix 3D tried to create like tools for education? So like you're dealing with so many people that have maybe unrealistic expectations. Do you have personal conversations with all those people ironing out the issues, or do you send them like a resource?
We do have, mainly we have conversations because we do like personal meetings with them, to just bring awareness to the technology, what's it all about. If they have a certain design or an idea that they want to implement, we kind of give them feedback on it. So it's a more interactive way than just like, sending them a manual saying what we can do and what we can't do. And the conversation is also important to have always, it kind of builds up that relationship also.
Yeah, certainly. Even if they have unrealistic expectations, maybe the technology will get there in the future, or seems certainly intriguing. So what's what's like one of the biggest challenges that you guys faced in the development?
I would say, like personally, the biggest challenge was the education, like to educating people, educating designers and architects, having that conversation. That was the biggest challenge, because oftentimes we ran into a situation where we are working on a specific project for a client that eventually we come to a conclusion that it's not feasible, it's not there's no cost benefit behind it, and we have to completely abandon that project, for example. So that was the hardest thing, that pushing and trying to make something happen, and then it not happening because of the the way that the design was proposed. I think now what people are realizing, and what we're trying to teach the audience, is that let's start together from the 0 point, and come up with a design together in comparison to having a design sitting in your shelf for years or months, and then you suddenly want to have it 3D printed because 3D printing can do anything. So I hope that we enter that stage where we can collaborate together from the beginning to kind of come up with a design that is feasible.
So I guess two common problems I can imagine are maybe people want to build things either too high or they want to build on too much of an angle. What other issues would arise?
Yeah, probably like also like having the openings in the wall structures, for example, because it's really difficult to have openings, especially if they're not a box shaped openings. If it's a circular opening, like how are you gonna achieve that opening in a 3D printed wall? It's really difficult to achieve it because it's not like plastic. In 3D plastic printers, you're probably familiar. You can either use support material to fill that void and print on top of it, or you can, because of the properties of plastics, you can build up that kind of inclination and that curvature to make the circle. But in concrete, it's not the case. So that's the things, that the restrictions in the production itself, the material itself, and the expectations what the people are proposing.
Sure. And then what about, do a lot of people contact you with projects where they want to include like electrical or plumbing in the project?
Of course. Because like it's like part of an architectural project typically would be those disciplines. So we're always faced with those questions, and we've developed some solutions also from those.
So are the solutions based off of traditional methods, like having the wire be on the exterior of the concrete? Or is there like any cool developments going on where you could maybe have the wire in the concrete? Or
so yeah, we definitely we had to use both techniques, newer techniques and traditional techniques. And one of those techniques were to actually embed it within the wall, within the 3D printed wall. Today, you see most of the projects are all of the services are exposed and kind of attached to the wall from outside. Why? Because it's the easiest way to do it.
Yeah.
And you don't really need to pre-coordinate it. But what we're trying to do, we're also trying to push that part of the project. So we have actually embedded services in the walls, which we're really happy that we went into that direction because we learned a lot. And also we have some kind of traditional ways of services. It really depends. Sometimes there are aspects that you can embed and some that you cannot, or different kind of restrictions. So whenever we have the possibility, we are trying to push it more towards having something more advanced.
Yeah, that's really cool. A lot of companies are kind of ignoring the plumbing or the electric. and they're just
Yeah.
building a structure and then using plumbing and electric as like an afterthought, saying like, okay, we built this, how do we include the electric and plumbing? Whereas I guess having more experience with general contracting, maybe you guys have the wisdom to kind of implement that as you go, knowing that it's going to ultimately be a critical part of the job.
Definitely.
Right now, do you think that having those kind of utilities in the wall, is that practical yet, or is it still more practical to use the exterior? Does that need more development?
It is practical today. It is practical today. Of course, because we are still using traditional services. Like we are still using the same conduits, the same piping, the same everything, the fixtures. We have to adapt it, or actually we have to adapt our 3D printing systems to those traditional fixtures or pipings. But what could happen, for instance, is that those companies specialized in mechanical, electrical, and plumbing services, they could also develop specialized fixtures and pipings for 3D printing. But whenever we have a possibility to use, as I mentioned, we are trying to use it as it is traditional. And sometimes when it just doesn't fit because there's no way to make them go together, we're having to expose them.
And you also have to adhere to the building code?
Of course, yeah. Yep, of course.
Is that a big challenge?
That is a big challenge, yeah. Mainly because there are no actual codes that exist today for 3D printed buildings. So to kind of find a segment where you would classify 3D printed structures and services in, that is still also a challenge for us. And it takes some time and a lot of back and forth with the government and government offices and so on.
Yeah, do they have time for that? Like, are they willing to look at your designs and like give you guys?
Of course.
They're interested in the technology.
For sure. I mean, the thing is, because it's Dubai and because there's a vision, they're kind of accommodating to it, and they have to, because if we do not start today, we will never be able to reach that percentage at the end. So there's a lot of positive feedback that we're facing, and there's also still the challenges of how to get it properly understood and classified within a certain kind of structure. One thing, Jared, so I'm fasting Ramadan. I don't know if you're familiar with Ramadan.
Yeah.
And actually, in 5 minutes, I'm supposed to break my fast. It's almost like 7 p.m. So if you don't mind, we'll have to stop it here. But I'm more than happy to finish it off or continue any later time if you would like to.
All right, that's fine. I think we had a really great conversation. We actually got through all my questions. It's like a celebration to break the fast of Ramadan, right?
Yeah, like, because every day I'm fasting from 3:30. It was 4:15 a.m. to 7 p.m. So every day I've been doing it for the last 3 weeks, and next week is the last week. It's almost like a month. So yeah, like I'm pretty hungry and thirsty, and I'm excited to break the fast.
Well, thank you for the time that you give me. Enjoy your meal very much.
Thank you so much.
And I'll definitely be in touch, talk about future projects.
I'm more than happy to stay in touch and talk about all of the new developments.
All right. Nice talking to you.
Yeah, same, Jared.
All right, later on.
We'll stay in touch. See you, bye-bye.